Hi guys, this is Kim and I did my presentation on bovine spongiform encephalopathy, which is commonly known as mad cow disease. So we'll start off with an introduction. So spongiform encephalopathies are also referred to as prion diseases, which are fatal neurodegenerative infections that affect humans and animals. Bovine spongiform encephalopathy is the scientific name for what is most commonly known as mad cow disease. And if we break this name up, bovine means that the disease affects cows. Spongiform refers to the way the brain of a sick cow may appear under a microscope, and encephalopathy means that the disease is in the brain. So what actually is BSE? BSE is a progressive neurological disease in cows. Since it is a neurological disease, it can only be identified and diagnosed by looking at the brain. So this is a disease that will get worse over time and cause serious damage to the cow's nervous system. So not only will the brain be affected, but also the spinal cord. And I'm sure you guys are wondering, well, why does this disease get worse over time? Well, this disease has an incubation period in which the cow may have and harbor the disease for a few years before it begins to show any type of signs and symptoms. So once symptoms do begin to show, the disease progresses pretty rapidly. And I'll discuss this a little bit more in a later slide, but I just wanted to introduce you guys to this on this slide as well. So causes of BSE. BSE is caused by an abnormal prion protein known as PRP. This is the protein that creates prions, and we know that prions are infectious proteins that misfold other healthy proteins, which cause neurological issues. So cows who become infected with a prion are unable to detect it is in their body. So they are incapable of fighting it off, which leads to the development of BSE. So how is it acquired? The main form is oral transmission, but other routes of transmission are being looked at, like gastric and cerebral transmission. Cows get infected by BSE from eating remains of other infected cows, which is very disturbing and pretty gross. But the way that this happens is that certain parts of cows that are not eaten by humans are made into a powder-like consistency and then used in animal feed. So if this feed is contaminated by the remains of an infected cow, then it will infect healthy cows that consume this feed. And this happens because the abnormal prion that causes this disease is still present in the remains of the dead infected cow. So just because the infected cow is no longer alive, that is not the case for the prion. The prion still remains alive and is the reason why it infects these other cows. So some signs and symptoms. The most common symptom of BSE in cows is that they become very uncoordinated. They can have trouble walking or getting up. Another major symptom is they can become very nervous and also very violent, which is why this infection was given the name of mad cow. Cows that acquire this disease go through an incubation period, which is typically around 4 to 6 years, until they finally begin to show symptoms. When the cow finally begins to show symptoms, the infection will progress very rapidly until it dies. And this can take up to anywhere from 2 weeks to 6 months. There is currently no efficient way to control this specific type of prion disease. So as of today, there is no treatment for BSE. There also is no vaccine for it. So who is at risk? BSE is only a disease that occurs in cows. However, there is a version of BSE that does affect humans. It is called variant Creutzfeldt-Jakob disease. For variant Creutzfeldt-Jakob disease, it is thought that the disease could be acquired from eating food made from cows that are infected with BSE. But I don't think that this has been I think that this is still being looked at and researched. But what we do know is that variant Creutzfeldt-Jakob disease and BSE are not contagious infections. So dairy products retrieved from infected cows will not cause BSE in humans. Other animals are at risk, like cats, sheep, goats, deer, and elk can all be infected with BSE. But it won't be the same version as it is for cows. But ultimately, they will all still experience similar symptoms like neurological loss, damage to their central nervous system, and a spongy brain. So there are 2 research case studies in this presentation, each with their own graph. So I'll introduce you guys to the first one. So this case study was conducted to further investigate random variations of BSE, like sporadic and atypical BSE. They focused on the ability to identify BSE cases in countries that are considered to have little to no risk of acquiring this infection, and also to detect a stable occurrence of atypical BSE cases in which oral transmission was beginning to disappear. So locations that had no cases of BSE or were considered a low-risk country, such as Argentina and Australia, had efficient nutritional practices and adequate surveillance of their cattle, which could have been a reason why they had little to no cases of BSE. Spontaneous acquisition of BSE, even in these countries, however, cannot be guaranteed, since infected cattle or cattle feed could originate from imperfect record keeping, lack of compliance, and deception of cow and feed quality. So I'll show you guys the graph that corresponds to this case study, but I will give you guys some background information first. So researchers studied the relationship between the likelihood that sporadic BSE would occur in regard to age. So it was determined that the cattle are more likely to acquire BSE between the ages of 35 to 84. So the younger that the cattle is, the less likely it is to be infected with BSE. Okay, so this is the graph. Here we have the number of cases reported in comparison to age. So as we can see here, between the ages of 0 to 14, no cases were reported. A few cases were reported between the ages of 15 to 19 and 25 to 34. But the majority of the cases that were recorded were between the ages of 35 all the way up to 84. And the highest amount of number of cases that were recorded were between the ages of 60 to 64. So like I stated earlier, the younger that the cattle is, the less likely it is to acquire BSE. But as it gets older, it becomes more susceptible to getting BSE or getting infected with BSE. Okay, so now we'll look at the second research case study. So this study examined a 9-year-old female monkey who was infected with BSE and also suffered with type 2 diabetes. So they examined samples of cerebrospinal fluid to further analyze the progression of the prion disease and to indicate if there had been any behavioral changes. Since the monkey suffered from diabetes, they wanted to know what type of effects BSE would have on the monkey. So they looked at things like body weight, plasma glucose levels, insulin levels, and insulin resistant levels along with age, and compared it to a control that was similar in age and characteristics as the infected monkey. So again, I'll show you guys a graph that correlates to this research case study, but I'll give you guys some background first. So the researchers concluded that the infected diabetic monkey had relatively increasing levels of weight, plasma glucose, insulin, and insulin resistance as it aged, and it would peak at a certain point, then drop drastically. In comparison to the controls had normal to low levels of all the characteristics that were examined, and the results were pretty consistent. So this is the second graph. So here we are looking at body weight in regard to age. So we can see here that the dark solid line is the infected monkey, and as it ages, it gained weight pretty rapidly until it reached age 7. After age 7, its body weight dropped very dramatically. And then in comparison to the control, which is the dotted line here, as it aged, it gradually gained weight, which is typically what we expect for a normal organism. So weight fluctuations in the infected monkey could have been due to the fact that it had diabetes and was also infected with BSE. So if we compare the two, the monkey as it aged, it lost weight, but the control as it aged, it gained weight. So what is some information that we can take away from these case studies about BSE? We know that effective nutritional practices and high level of surveillance could lower the rates of BSE transmission. BSE is also more invasive and infectious depending on age. And BSE could cause inconsistent patterns in weight gain and weight loss. So that brings us to the end of my presentation. I hope you guys enjoyed it, and I hope I did a good job of presenting you guys with this information. I hope this video wasn't too painful to get through. I know that I covered a lot of topics, and the research case studies were probably a little bit much. I did my best to summarize them. I did provide you guys with some review questions here, and these can all be answered from my PowerPoint. So if you want to go back and answer these questions from notes you took and stuff like that, please feel free to do that. If you guys have any other questions or concerns, please feel free to ask me, and I will do my best to answer them to the best of my abilities. But this concludes my presentation on bovine spongiform encephalopathy.